All right, so let's go ahead and take a look at what it looks like when the switch is off. So how would I go ahead and turn this switch off? Well, if right now I have the plus higher than the minus and that turns it on, and I know that all I need to do is make the plus smaller than the minus to turn it off, let's go ahead and just switch what we have connected to the plus and the minus terminals, right? So I can just go ahead and, instead of connecting that there, I can connect it to the minus terminal, the 5 volts, and then I can just ground the plus terminal. Right? So that should turn my switch off. And what happens when my switch is off? Well, my switch presents a 100 mega ohm impedance or a 100 mega ohm resistance, right? So it's not an infinite resistance, which means I won't get zero current flowing through the resistor. Rather, I'll get whatever 5 volts divided by 100 meg plus 5K is flowing through my resistor, because now I'm going to have a 100 mega ohm resistor, which is this switch, when it's off, in series with my 5K, okay? So this isn't an ideal switch, but in most cases it behaves pretty close, so we don't really need to worry about it. But I just want to let you know we're not going to see zero current flowing through the resistor, but we're going to see basically a negligible amount of current flowing. And we're not going to see 0 volts at the 5K terminal or at the VR, but we're going to see a very small voltage, something negligible, okay? Because basically that tiny current flowing through my 5K will result in a voltage drop, and I will get some non-zero voltage here, but it's, for all intents and purposes, it is negligible. Okay, so let's go ahead and run this sim, and let's see what is my voltage here. It is 250 microvolts. Oops, let me move this, and we'll put this back. 250.0125 microvolts, okay? And then what is the current that I have flowing through the resistor? 5 times 10 to the minus 8, so 50 nanoamps flowing through this resistor. So for all intents and purposes, zero current, zero voltage. But just so you know that we're not going to actually see zero, because this resistance, when the switch is off, is not infinite. It is 100 mega ohms, which is pretty large, especially in comparison to this 5K. Okay, so I just wanted to show what that looks like when the switch is off, and I'm going to just go ahead and end this video here, and then I'm going to make one more video after this to show one more application that we can use to drive the switch and to turn it on and off in a transient circuit. Okay, go ahead and end this video.